So in this lesson, we're going to be talking about how we can write equations from a story, from a word problem, to represent some kind of a quadratic equation. Basically, what we're looking for is to find different words that are going to imply that we can write a variable squared, like an x squared term. So that's our idea. We'll read our sentences, we'll see if we can write our equations. The equations will be quadratic equations, and then we'll solve them using our different solving techniques that we have. So our first one, 5 times a positive number subtracted from the square of the number is 66. Okay, so I'm starting off here and I'm thinking I need to find a positive number. So I'm going to write that I want x to be my positive number. I like to remind myself what my variable is that I'm looking for. So then it says 5 times a positive number subtracted from the square of the number. The square of the number. So there's a little phrase right there that's going to tell me that I'm squaring a number. What number am I squaring? I'm squaring x squared. I'm squaring x to make x squared. So let's see if I can write this equation. 5 times a positive number. So that's going to be 5x. Subtracted from, I remember that phrase subtracted from. Subtracted from means I'm taking that 5x away from something else. So I'm subtracting it from the square of a number. And that is 66. Okay. Well, I got an equation. Can I solve this equation? So I think I might solve this one by factoring. Remember, there's a lot of different ways to factor. We can, or solve equations. We can complete the square. We can do the quadratic formula. We can do factoring. For this one, I'm going to do some factoring. So first, I'm going to set it equal to 0. I get my x squared minus 5x minus 66 equals 0. I look at this and I say to myself, okay, it's a trinomial. There's no common factor. So I'm thinking what I need to do then is I need to find two numbers that multiply to 66. And that can combine to give me a 5. So x squared gives me x and x. 66, I'm thinking like 11 and 6. And negative 11 and a positive 6 will give me a negative 5. Great. Let's set our two factors equal to 0. The 0 part where it says multiplying two things together, and their product is 0, that one of them has to be 0. So if I solve these equations, one of my answers is negative 6. The other answer is positive 11. Now notice in this case, I got two answers, but my question says to find the positive number. So my negative solution, even though it's an answer to the equation, it's not really the answer to the problem. So what you're going to be doing is, I'm going to take this extra answer, and I'm going to reject it. I'm just going to cross up, although it's a solution to my equation, it's not an answer to the problem. So what's my positive number? My positive number is 11. So I wrote a quadratic equation and I solved it. So today's focus is going to be on writing those quadratic equations. Let's see what else we have. One positive number, 3 more than another. Interesting. Some of their square is 89. And find those two positive numbers. Okay, let's go with variables. One positive number is 3 more than another. So I'm going to say this x is smaller one. And then x plus 3 will be larger. One number is 3 more than another. The sum of their squares is 89. Okay, let's break this down. It says sum. I think when operation do sum for sum, I do addition for sum. So let's add. What am I adding together? I'm adding together their squares. Whose squares? The two numbers square my two numbers. So my first number that I'm going to square is x. The other number I'm going to square is x plus 3. And what's true about the sum of their squares? Equals 89. So I got an equation. I translated all that
mathlish to English, or English to mathlish. I wrote a nice algebra expression. I'm ready to solve it. So I'm looking at that second term, that square of x plus 3. And I remember from my work with expanding binomials, that this means multiply x plus 3 twice. And when I multiply that out, I get x squared. The outsides give me 3x. So the insides give me 3x. I get another positive 9 there. So all this simplifies to x squared plus 6x plus 9. Let me bring down my 89. Let me bring down my x squared. Combine some like terms, and we set equal to 0 as well. I get 2x squared plus 6x if I subtract 89 from both sides. I get a negative 80, and that equals 0. Alrighty. So I'm looking at this trinomial. I have a 2x squared, a 6x, and a negative 80. I recognize that all three terms are multiples of 2. So there's a GCF of 2 in here. So let's factor that out. And let's write it as 2 times x squared plus 3x minus 40 equals 0. Now here's an interesting little thing. I noticed that I have 2 times something, this trinomial, equals 0. My 0 property says that one of those two things, either 2 or the trinomial, has to equal 0. Well, I know that 2 doesn't equal 0. So because there's just a number out there, if I divide everything by 2, or if I do my 0 property, all I'm going to be left with is just the trinomial equals 0. And that's something that we can solve. We're looking for two numbers that multiply to 40, combined to 3. How about x plus 8 and x minus 5? When I do my 0 property, I'm going to get x equals negative 8. My other 0 property gives me x equals 5. And if I go back to the beginning of the question, I believe it said to find positive numbers. Gotcha. So let me go back down. Take a look at my answers. Negative 8, not going to worry about it right now. So x is going to equal 5. That's going to be my positive number. So let's see, my two positive numbers then. One of my numbers is 5. The other number is 8. So those are my two positive numbers, 5 and 8. So what you might want to do now is hit pause on this video and take out the worksheet that you have and do numbers 2 and 4. Those are problems that are kind of similar to these, and I think you'll find some success if you practice through a few of those. Don't worry, I'll wait here for you. Okay, welcome back. Let's talk about doing another problem here. Often when we talk about an x squared or a quadratic equation, we bring in area, because area of a rectangle, remember, is length times width. Area is represented in square units. So it really gives us a lot of opportunities to write word problems that involve quadratics if we talk about the area of something, specifically rectangles, because rectangles are usually length times width. So I'm looking at this question. The length is 6 more than the width. Let me draw a picture of what's going on. So the length is 6 more than the width. I don't know how long the width is, so what if I call it x? And then my length is x plus 6. And I'm told that the area is equal to 72. So I remember that if I multiply my length and width, I get my area. So let me multiply my length and width and make it equal my area. So when you see these rectangle problems, you're thinking about multiplying a length and a width together of some sort. Well, is this an equation you can solve? It sure is. So let's do our distributive property. Now, you can set it equal to 0 if you want and factor it. I'm looking at this, and just to me, it sets up to complete the square. So just to review a little completing the square, let's play with it. Let's see what we can do. What you might remember to complete the square is if you take that middle number, the b value, and divide it by 2 and square it, that's the number that we're going to put in the box. And remember, there's a box on both sides. 6 divided by 2 is 3. I square it, I get 9. Let's not write plus 9, let's write equals 9. So 9 is the magic number. 9 goes in the box there, and 9 goes in the box there because it's an equation, same thing on both sides. So now remember that when we complete the square, we can write it as a perfect square trinomial. 72 plus 9 is 81. Oh, I like where this is going because 81 is a perfect square. So now when we factor this x squared plus 6x plus 9, we factor by some square roots. Square root of x squared is x. Square root of 9 is 3. Or maybe you take half of 6. That's good. Now I'll do my 2 steps. I'm going to just take the square root of both sides, remembering that on the right side I get plus or minus 9. And then I move my 3 over. So I get here x equals negative 3 plus or minus 9. If I do those two values, negative 3 plus 9 is positive 6, and negative 3 minus 9 is negative 12. So now, I solved the equation. What did the question ask, though? What are its dimensions? So dimensions mean what's its length and what's its width. We need both for the answer. What's the length and the width? Well, lengths and widths are positive numbers. I would never ask you to measure a negative width. So let's cross off that negative 12. We don't need that as part of our answer. Good answer for the equation, not a good answer for the problem. So if I go back to my rectangle then, my width was represented by x, so my width is 6. My length is 6 more than that, a length of 12. And maybe you figured out already that length times width, 6 times 12 is 72. That's our area. So after doing this area problem, maybe you have some confidence to try numbers 1, 6, and 7. Give those a shot on that worksheet. Don't worry, I'm not going anywhere. Come on back when you're done. Okay, there's things that we do in math called consecutive integers. There's a special type of a man-made math problem that involves consecutive integers. So let's talk about what they are. Consecutive meaning coming one right after another. So maybe some consecutive integers, if we started with, say, 5, the next one would be 6, and then 7, and then 8, and so on. We could have negatives as well. We could do negative 4, negative 3, negative 2, and so on. But let's say we want to get creative and we started with x. Well, what would we do to x to get to the next consecutive integer? Well, what do you do to 5 to get to 6? Well, you add 1. So what if we said you add 1 to x and get x plus 1? Well, let's keep going. What do you add to 6 to get to 7? You add another 1. What do you add to 7 to get to 8? You add another 1. So if I take this x plus 1 and I add another 1 to it, I get x plus 2. And then I get x plus 3. And I can continue with those for as many as I need. So that's how we represent consecutive integers. And yep, we can do even integers as well. So some even integers, things like 4 and then 6 and then 8 and then you know the rest. Let's say I started with x. Now ask yourself, what do I do to 4 to get to 6? Ooh, this time you go up by 2. And then what do you do to 6 to get to 8? You go up another 2. So please notice that x plus 2 is really x plus 4. Also notice that with the example in the numbers, that if I added 4 to my starting value of 4, I would get 8. So yeah, I'm really going up 4 from where I started. X plus 6 would be next. And we could continue going up by those even numbers. Now check out the odds. This is where we have some fun. So if you think about a bunch of odd numbers like 5 and then 7 and then 9, and you can keep going there. If we started with the smallest number being x, our first integer being x, what's the next odd integer? What do you do to 5 to get up to 7? Yes, you add 2. But wait a minute. 2 isn't even. It's an even number. It's not odd. We're doing odds. You're right. Don't odd numbers go up by 2 as well? So then after x plus 2, we'd have x plus 4, and so on. So even and odd integers still go up by 2's, where the regular consecutive integers just go up by 1's. So let's see how this works in a problem. Let's say we want to find 2 positive consecutive integers whose product, let's think about that word product. Product is what you get when you multiply things together. And the product's going to be 132. So let's think for a minute. Let's say that x is my first integer, my first consecutive integer. Now, I don't really want evens or odds. I want regular consecutive integers. If I go back for a minute, my next one would be x plus 1. If my first one is x, my second one's x plus 1. That's the one I want. So x plus 1 is my second consecutive integer. All right, it's equation time. Find 2 positive consecutive integers. I have them represented by x and x plus 1. The product, when I multiply them, I get 132. So when I multiply these consecutive integers together, I get 132. Okay, the translation's done. Can we solve this problem? Can we set it equal to 0? Can we factor? Can we do completing the square? You want to do quadratic formula? We could do that too. So if I distribute, subtract 132, I get that equals 0. Ooh, that's an easy one to factor though, because I know numbers that multiply to 132. Do you remember that 12 times 11 is 132? If not, you go to your calculator and play with that a little bit. And to get my signs right, I need a positive 12 and a negative 11. We make it equal 0. Let's do our 0 property. You know what to do from here. Don't do what I did, though, and get those signs wrong. X equals 11 and x equals negative 12. Now, again, the question says we want positive integers. Do we always want positive integers? Not always, but just be aware sometimes we might look for a negative. So our 2 integers then? We know that the first one is x equals 11. And then x plus 1 is going to be 12. So the 2 integers are 11 and 12. And you might notice that the negative 12, it's the opposite of the 12 in our answer. Well, negative 12 is still an integer, and if we add 1 to it, we get negative 11. And if you multiply negative 12 by negative 11, you do get positive 132. So it does work in the equation. It's just that they ask for positives, so we get positives. So based on this, you might be able to try questions 3 and 5. So hit pause, try questions 3 and 5, and come back in a minute or two. All right, these last 2 are really fun. I enjoyed these problems, and I hope you do too. So a picture is in a frame of uniform width. Okay, so let's talk about what uniform width means, that the width of the frame is the same all around. So a picture of it might look something like this. Here's my regular picture. And then I put it in a frame, and I'm going to try to draw it so that the frame is the same width all the way around. It tells me that the dimensions of the picture are 12 inches by 16 inches. And the area of the frame and the photo, so the whole area, that total area is 320 square inches. So now, if we're talking about this idea of a uniform width, what that means is I have the same width all the way around it. So that distance there is the same as the one here, same as the one here, same as the one here. All those widths across are exactly the same. So really, this goes back to being another one of those area problems. But let's see if we can write the dimensions of the length and the width. So if I want to draw the width of this, the width is going to be this segment in green. So notice how long it is. This part here is represented by x. It's the width. Then when you get to right about there to right about there, it's the picture frame's width, which is 12. And then I got another x there as well. So if I add those together, I get an x plus a 12 plus an x. So the width, and I'll write it up top, is 2x plus 12. Take a moment, see why that's 2x plus 12. I added the two widths of the picture frame and the width of the picture. You might be figuring out then that the length is going to be 2x plus 16. Same idea. You got the length of the picture and then the two widths on either side, the two pieces of the frame. So check it out now. We got a length, we got a width. Let's multiply them and get an area. So 2x plus 12 times 2x plus 16, and that equals 320. Oh boy, big equation. Well, can we multiply it out? I'm sure we can. Let's go do that. So if I multiply my 2x's, I get a 4x squared. 2x times 16 is 32x. 12 times 2x is 24x. 12 times 16 is 192. And that equals 320. Shall we set it equal to 0? Let's go and do it. So when we set it equal to 0, we'll subtract 320. Four x squared plus, let's see, if I combine these, I get a 56x. If I subtract that 192 over, let's see, 10 minus 2 is 8. 11 minus 9 is 2. That's not 228. I'm doing some bad subtraction here. There we go. That looks a little bit better, 128. You know what I should do? I should open up my calculator. Let's get that thing going. So let's see. Oh boy, how do you want to factor this? How do you want to solve it? You know, big numbers scare me sometimes, so I'm thinking because I see some big numbers, I might just go right to the quadratic formula and let my calculator do all the work. So this is my value for A. This is my value for B. This is my C value. Let's go to the quadratic formula and see what happens. So x equals negative B plus or minus the square root of B squared minus 4 times A times C. All divided by 2 times A. All right. Hey, now we just got to go to the calculator and type it in. So let me pull up my calculator. So I want to type this into my calculator. So I'm going to enter in the fraction bar first. And let's see, what do we got? Boop, 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 boop. There we go. So we got negative 56. And let's do the addition first. Plus the square root of 56 squared. Subtract 4 times negative 128. And we're going to divide all that by 2 times 4, which is 8. But I'll write 2 times 4 just so you see how I plugged everything in. And let's see what we get. We get 2. Now remember that there's 2 answers here. So I'm going to go up and I'm going to hit that enter button to bring it back down. And let's go change that addition sign to a subtraction sign. So my 2 solutions for x are positive 2 and negative 16. Let's bring those over. So this gives me answers of x equals positive 2 and x equals negative 16. But again, I'm looking for the width of the picture frame. So a width can only be positive. So let's cross that one off. And let's say that the width is 2 inches. Very nice. Good use of the quadratic formula there. One last one to play with. Let's take a look at this. 60 feet of fence available to make a chicken coop. So the chicken's going to be running around here, and he determines that the area of the coop needs to be 216 square feet. Okay, little fact on the side. People who sell chickens actually recommend a certain amount of square footage per chicken, because you don't want to put like 1,000 chickens in a little tiny area. You want to give them their room to live. So this is interesting. 60 feet of fence. We're going to make a rectangular chicken coop. So when I see this 60 feet of fence, I think that's the perimeter. My perimeter all the way around has to be 60 feet. So would it make sense then that if you add up 2 sides, because the whole perimeter is 2 lengths and 2 widths, and we want that to be 60. So wouldn't it make sense that the length plus the width had to be 30? So we got to make 30 feet totaling 2 sides. Okay, so then why don't I do this? Why don't I call this side x? And then because those 2 sides have to add up to 30, or better yet, instead of calling it x, let's be a little different and call it w. So then if I go back to my equation and I solve for length, my length is going to be 30 minus w. And that should make sense to you. Let's just pick some numbers real quick. If my width was, say, 10, then my length is 20. And then I get 10 plus 20 is 30, plus the other 10 and 20 makes 60. So there's my 60 feet of fence. So those dimensions look good. Can we write an equation for it? Let's do that. W times 30 minus w, length times width equals 216. If I distribute, I get 30w, subtract w squared equals 216. And one thing I like to do, I like to get my w squareds to be positive if I can. So let's see, maybe we'll move that w squared to the other side, and we'll subtract 30w. Alrighty, but I got to put that side in standard form then. So I get 0 equals, let's put my w squared first, subtract 30w, plus 216. So I need numbers that multiply to 216, but can combine to give me a 30. Let me play for a minute. Multiplies to 216. I wonder if 216 is divisible by 12. I think I got it. Holy good guess, Batman. 12 times 18 is 216, and 12 and 18 make 30. That was a pretty good guess. Wow. Alrighty, I'm ready to factor this then. 0 equals. Let's see, I got to make them both negative. Hey, you know what? If you're not as lucky as I was on that, quadratic formula is your friend. You want to complete the square, you could do that. A lot of good things to do there. So let's see, I get w minus 18 equals 0, and w minus 12 equals 0. So if I solve, I get w equals 18, and I got w equals 12. Oh no, I got 2 positive answers. Which one do I cross off? Well, let's think about it for a minute. If the width was 18, wouldn't the length be 30 minus 18, which is 12? And if my width was 12, wouldn't my length be 30 minus 12, which is 18? So my width could be one or the other. It doesn't really matter which side we call the width. So let's answer our question then. The question says, determine the dimensions of the chicken coop. So the dimensions are going to be 12 feet by 18 feet. That would give us an area of 216, and we'd use all 60 feet of fence. Very nice. So after this, you should be able to finish numbers 8, 9, 10, and 11. Do your best on them. Refer back to these videos if you need to.